Yeah, my name is Patrik. I've been in Tacton for 4 years, working as VP Product Management, and before that I spent more than 20 years in the manufacturing industry, working with different aspects of product-related systems and information. And today I will see here. Today I will talk about the subject of product data management and how that's and the importance of that when it comes to CPQ, and really the key essence of that to have a successful CPQ implementation. But I start a bit on the challenges our customers are facing having a big variance. So these are the type of customers we have been able to support for different industry, and all of them have more or less the same type of problem. They having products with high complexity, and they need to manage that in a good way between sales, product engineering, and factory and supply chain. And this is not so easy. This is a very, let's say, a difficult problem to solve, so to speak, and it creates a bigger hurdle. And if we talk about complexity here, we talk about really big complexity in some areas, and having this kind of product we see in front of us from one of our customers, it's 10 to 150 of potential problems, and that it's not so easy to handle, but that's what the customers need to handle, and we really can help there, that's for sure. So if we look at this, handling this problem, if it's not done well, you need to spend a lot of time creating quotes, and fairly a lot of them not actually become orders. So you waste the time, and a significant 30% of the orders are then having errors, and that means that it's actually then also margins lost during order fulfillment, and actually lost revenue due to slow time to volume, so to speak. So this complexity, if it's not handled well, it creates a lot of issues, but it can also be changed to, if you can manage this in a good way, you can have a good benefit of this, so to speak. So basically the bottom line, if you don't manage this well enough, actually decreased revenue is a result. You have increased cost and risk increase, and weakened brand at the end. So these are the problems, which is really important problems for the manufacturing industry, having high complexity, which we are helping with and are good at, so to speak. So we talk about the Tacton way. What are really the differentiators? How can we do this well, so to speak? And one is what we are really good at with our software and our expertise, is to actually help the customers to navigate the complete portfolio. So it's basically not just to support the product, let's say the offering from a sales perspective, but you also need to have engineering and order fulfillment involved and aligned, so to speak. So if we start with those different aspects, so of course you start with the customer needs. So so that's really important to capture that, so to speak, to really making sure to convert those customer needs into a, let's say, a best offering, so to speak. But also the compliance is important. How can the customer make sure that this is compliant? Maybe it's a pressure vessel code, or it's something else that needs to be compliant, or legal, or something else. can be traceability, or yeah, something different. Commercial rules. How do we know that we are offering the best margin? How do we know the prices up front? How do we know that this is going to be a profitable offering, so to speak? So that's also important. Serviceability. How do we know that we can also add services? How can we offer a complete solution? And when it becomes an order, how do we know that the order fulfillment process is aligned? How do we know that this is going to be possible to produce, but also that it's going to be actually good lead time and all that aspect, so to speak? And of course, the technical aspects. How do we know that this is actually a valid specification? How do we know that this is a complete, correct, and solution we are providing for the customer needs? So that's one of the challenges we are really good at managing with our technology. So if this is done well, we look at three key differentiators here. And first of all, is the obvious one in the sales tool, is in the omnichannel experience, is to automatically convert the customer needs into 100% validated in detail technical solution. So this is a really key that the sales people, could be direct sales, partner sales, or even self-service, that have this confidence to do this. But then also to automatically create it to a quote with a best competitive offering, having alternatives, yeah, all that stuff, so to speak. But then when the quotation is done, it's actually it's possible to convert this quote into an order which supply chain can actually act on, and actually it's detailed enough to actually support the order fulfillment process. So these are usually the end result of the CPQ, and that's where you see the real value of the investment. But to get there, you actually need, let's say, our customers need a common language and a way to work between sales, supply chain, and operations. So when it comes to product information, this is one of the key to have a successful CPQ. Of course, the CPQ is at the end used mainly in the sales area, but you need to make sure you have the product development and management, supply chain, and the sales marketing line. So if we start thinking about these three functions that all manufacturers have, I mean, everybody in manufacturing have factories, they're doing mainly physical equipment produced in factories, and they have an R&D defining that, and the sales and marketing. So these three functions, if you start to think about that, they have all demands and requirements on having product information. So, but a bit different. So if you look at the start with the sales and marketing, they here, of course, obvious, they need configurators, product catalogs, drawings, manuals, promotion materials. So it's more commercial product information, so to speak. In development, you have demands for specification, calculations, 3D models, bill of materials, and other materials, so to speak, specification. And in supply chain and service execution, they have a bit different. They have quality approvals, bill of materials, but a bit different. So I will talk about that more later. And drawings, service instructions, and spare part lists. So they all have product information, but they need a way to collaborate on that, so to speak, to have a good common understanding of the product, so to speak. So if you look at this, there is a need to create a common language, to have these different functions and the system they have to really work together in a good way to make sure that you can achieve what I talked about before, having correct usage to correct solutions, and then be able to transfer it to supply chain and so on. So the common language is very, very important, and to create to be able for engineering, sales, and supply chain to collaborate. And the obvious system, if you look at sales, they have typically a CRM system to make sure to keep track of the customers, sales ERP, but also they need actually a capability to have the selected product variants for the sales configuration defined, and usually that's a CPQ. But in engineering, they also have the PLM, the CAD, but they also need to basically describe the technical aspects of the product variant, so to speak. And then supply chain has to be aligned and being able to understand this common product architecture or this common language between the functions, so to speak. And it's also vital to have based on this common product architecture or language, defined processes. So actually engineering can start defining the technical aspects and collaborate and work with supply chain on the lower supply chain introduction process, but also in parallel work on the sales introduction process to sales, and then of course sales and supply chain to collaborate in the quote order process, and that's more the obvious. And looking how many customers work, it's the sales introduction is very seldom really connected to engineering, and usually you have very disconnected when it comes to the, let's say, architecture, the common architecture, and the let's say the variability and the constraints. The engineering is usually working on an engineering configurator, which is very disconnected from the sales aspects, meaning that the time to value and that collaboration between engineering and sales either are going via supply chain, which makes it really slow because you start developing something and then you actually introduce it to supply chain, and then after a while you start also to introduce sales, but that becomes very, very inefficient, and so this is the way we really like, and this is how we can really help out here to manage this. So this is a really common problem we see, that the engineering and sales are really disconnected, and this is a really important aspect to have a successful CPQ that's working over time, so to speak. So this common language has to be described in some kind of way. So actually, this is an example of an information model, and actually this is the information model which we have implemented in our product modeling tool, but I come to that later a bit more. So the left side is really the data structure. So what you want to do is have one place where you define the structure, and the right side, it's the constraints in that structure, and you also want to have that the constraints defined in one place and in an efficient way, so to speak. If we look at the left side, there are some aspects of this common language which are important. Of course, you want to have an assembly of this product architecture that is talking about positions. So positions is something really important in this information model to be able to cover. For example, the positions of the 4 different wheels on a car, that's an obvious one. But there are some other positions so the positions are really important to capture in your architecture and agree upon between engineering, sales, and supply chain. Then a module is defined. You want to modularize your product because you want to basically have a way to have mass configuration, unique units based on standard components. And so you want to divide your product in modules. And these modules are defined by its features, a set of features. Then you have variants, which is defined by its feature value. So basically it's the combination of feature value. And then you want to have parts realizing the module variant. So one really important aspect here is that one of the aspects you want is actually to differentiate between the variants, the module variants, which is defined by its feature values, and the realization of that. And I will talk a bit about why is this important later, but this is not so common that you do that, but it's really important. So you can actually separate the realization of these variants from the definition of its feature values. And then, of course, to the right side, it's really important that you're having a really good way to define the constraints in this. So with this common language, which we have in our product, I will try to animate how this information is created and managed, so to speak. So let's say you have now created this definition of the common language. So you have a product with position, you have created modules with variants. So when you're doing a new product development process, you actually start usually in engineering to define which are these variants we are actually going to have as a result of this product development. So that's the first thing, to define which are the variants we intend to have in this new product development process, the new initiative, and actually already with these steps also defining the technical rules and constraints in this language, so to speak. So you can already with this actually start already to, let's say, describe how well will we actually be able to solve the let's say the specification of this new product development. The next step is actually that engineering is starting to implementing this structure with the variants in the PLM system. And here actually start to realize these module variants with the engineering part. So in this picture here, the engineering parts or the engineering assemblies are described by a blue box, so to speak. And in this case, the engineering bill of material are describing, let's say, how the product should be realized. And the top assembly is here a module variant. These variants are then sent over to supply chain, where each factory are actually then defining the red parts, the manufacturing parts, and they can be of basically two kinds. It can be raw materials and it can be semi-finished parts, and then you add the routings. And to think about here that these manufacturing bill of materials that you see on the right side, that will be the result of this, they will be unique for each factory. So if you have a product produced in different factories, the manufacturing bill of material will be a bit different, depending on how they have set up the process, the routings, and how they are sourcing raw material. Parallel to this introduction in supply chain, also the same structure with engineering constraints are actually sent to the sales preparation process, where sales actually structures for, let's say, sales is added, could be system level or some other level, and the sales logic is added to that. So you're really reusing the structures from the engineering, and you add the sales logic to that. Pricing, optimization, we talk about regionalization and things like that. So basically the same structure is used, and actually you shouldn't have too much engineering parts in this. And so actually you say that the structure here is defined by its module variants. So that's the end of the, let's say, realization projects of the new development. So you have started to do the structure in the common language of product, position, modules, and module variants in engineering. You realized them in engineering with the engineering parts. You have actually sent them over to manufacturing, where they have prepared the manufacturing boom for these, and you have in parallel actually also prepared it for sales. So now we're coming into how this is used in the sales process. So actually, when you have done a configuration in sales, the result will be a sales bill of material, where you actually have module variants in a list of module variants in position, so to speak. And those will also be, let's say, having two functions. One is to support the sales process with pricing and all that stuff, but also actually when you get the order, you will actually be able to send those down to the supply chain, where actually based on the preparation of the module variants to the factory, based on this process, actually the manufacturing can then basically create a specific product boom, product manufacturing boom, you could say, for this particular configuration, for this particular factory. So this product boom will be different if it's then produced in factory A versus factory B producing the same product. So this is the idea about this kind of information model we support. So this is a summary of how this information is, so to speak, created. So each information object should only be created in one system. So there are some fundamental things here. So first of all, I talked about the module variant will become the, let's say, the common object, which is, let's say, known by each corner in this triangle. It's known by engineering, sales, and supply chain. And to think about, why don't you want to have engineering parts in sales too much? So let's say you have a module variant realized by an engineering part. You then engineering gets a claim. And so they actually do a new revision of that engineering part. And if that engineering part is then actually released to supply chain, depending on how critical this introduction is and let's say the stock in the supply chain, this engineering part, the new revision of this, that can be introduced in the different factories in different times. And if you are having too much details on the engineering, let's say, boom in the sales system in CPQ, you actually need to take care of that in your CPQ system, and it becomes super complicated. So you actually have to think about, okay, even taking care of the stock in reality of each supply chain. And you don't want to do that. You want to keep that in the supply chain processes and those details to avoid. So to speak. The same is if you look at the supply chain and the different, let's say, we talked about the same configuration will have a different manufacturing boom depending on how you set up your supply chain. And this is not details you want to have in the CPQ either, because then you need to keep track also of those details. And let's say you have a simple approach. You have a product supplied in one factory only, and you have a lot of details, manufacturing details in your CPQ system and in your sales boom, so to speak. Then somebody says, especially now with the volatile supply chain, saying, we also want to produce this new product in also this factory over here. And the world is not so standardized as you like to have. So you actually now will have a different manufacturing boom. If you have implemented too much detail in your CPQ, you actually need to probably start to say, oh no, we can't produce this new product in this new factory because we need to change this logic in CPQ system, and it becomes really complicated. So you don't want to have that. So that's why this information model is defined like this, to think about, to have a common language, to have speed in the processes between sales, engineering and sales, engineering supply chain, and sales and supply chain, but not too much details to make it too complex, so to speak. So that's what this really talks about, so to speak. So this is what you can do with this kind of thinking. And the good thing is that we actually have a really good solution. So you could see it as we have now really our new Tacton product modeling, which actually is some kind of different. It's part of our admin tool. It's actually having a really good information model to actually manage this common product architecture. It's possible to start using that already in engineering, to start describing the technical aspects, the technical constraints in the common language, and to introduce that, it's actually the same language as used in CPQ. So the introduction from engineering to sales can be really working in a much more fast way compared to having disconnected islands, so to speak. And you don't need to go via supply chain to introduce product in sales. So this is how you can do it. So this is also, you have your PLM, and you have, usually PLM is not very standardized. You do things in a fairly different way. You can then integrate that with our promo or product modeling and engineering via the API. And you have the structure, you share the structure, and you can either create the structure first in PLM and integrate that to the engineering, the product modeling in our tool, so to speak. And then you will manage the constraints in product modeling. So you actually don't want to create, so you have the constraint in one place, so to speak. So this is an example how we can do this and use our product modeling very, very well with the PLM already in engineering. So we have done this. We have already some customers working in this way, already starting to work with product modeling and this way of working already in engineering, connecting engineering and sales and also having supply chain connected in this way. And if we look at the results of this, so this is one example of a customer really having an engineering design process where you start basically to work in our tool. Already here you see it create product type, analyze up the upper left here, to really start working with with the architecture already in the language of product modeling, integrate that with PLM already here, and really have amazing results, so to speak. So talking about this achieved result, so we have customers that actually have been able to reduce the time to market from months to days due to that engineering and sales are working with the same language and basically using the same tools to collaborate in. And also have a much more predictable time to market, to less rework late in the process. So before, engineering was working on their structures in their way, not having any idea about how is sales configuration basically implemented, meaning that engineering did something, and then when you start to implement it in sales, there had to be a lot of rework done. This also increased the quality. Of course, having the same language, you know what you're doing. This was really a important aspect. And in this case, self-service for configured product was really an important thing. And the increased quality of the let's say the data and the data for the in the self-service channel was really a prerequisite, and by working this way already, connecting engineering already to self-service was actually a great success and actually a prerequisite to actually succeed in the self-service channel. Because before, in the direct sales channel, it was actually a lot of gaps where the direct sales people needed to fix things and so, and because they know the data was not correct enough and the rules and constraints. There are also really interesting things by having engineering already start to work in this kind of having the visibility, transparency of this structure, the language. Actually, they got actually start to looking at the physical design and the product complexity, and in some cases start to think about, okay, we have, let's say, a handful of different solutions for the same problem, which creates a lot of complexity in the structure, so to speak, and the configurators. And actually, they started to decide to, let's skip this different solutions to actually balance the complexity with the physical and logical complexity, so to speak. And this was also in this case CAD automation, where was really a really important aspect of the CPQ implementation. And before, there wasn't CAD automation available, but it was actually not based on the CAD data engineering has done. It was a separate island, so it also took a lot of time to implement that. Each time there was a new product going to be introduced. So this was a prerequisite to get CAD automation using engineering's CAD for both sales and supply chain. I didn't show that in this case, but so actually in this case, the CAD automation was totally automatic from the sales configuration, and it was actually both possible to do, let's say, more simplified, fast sales, specific CAD automation, part of the quote, but also detailed one for the supply chain with all the details in 2D and 3D. So